All right, welcome back. So we've done the grains kickup effects for the ground stuff. Now we'll show you what I've done for the dust. Let's have a look. That is pretty neat. Let's have a look at. Very cool. Awesome. So this is technically the same setup as the grains. If you have a look at the pop network, we've got the same forces: pop force, the pop drag, wind, and axis force, and also the SOP solver that has the deformation thing that we've done, like the grains kickup. Um, I've also added an attribute blur for the velocities. I'm making sure that it's set to proximity instead of connectivity. Um, that's because these particles don't have any connectivity information towards them. They're all unconnected. So setting it to proximity, it's based on spatial radius. All right, so I'll show you how I've done the source. The source is just using the debris source node. So if you put down a debris source node, you get the simulated or rest geometry for the first input and the simulation points. So you just grab. So this is on the left side here is my fracture pieces. I haven't placed any. This one doesn't have any transformation on them. It's all just the static frame. And then I don't think we need that. So and then all I've done is take the rigid sim points and plug it in here. And so, cool. So if we just tell the debris source to have the rest frame 1065, because that's when these points start to explode. 1065. So I'm setting it to 1065. If we have a look at our debris source, boom, that's pretty cool. So we can set the lifespan lesser, and we also got remove the unreleased, meaning pieces that haven't been broken. We don't need them in the source. So if you just say remove unreleased, and it removes that thing for us. And also, when the lifespan of these particles hit this threshold, then we can kill it. So that's what we get. Boom. Pretty cool. And what else have I done here? Taking in the density as well. All right, so with the debris source, you can get the density of these points as well, how much these things are scattering onto the pieces. And another thing that I want to show you guys is, since I wanted to add an ID for these pieces, so if you have a look at this guy, yeah, so the reason why I unlocked the debris source is because I just wanted to have this cluster ID to be copied onto the points. So if we just have a look, run the sim. I'm not getting that cluster ID. If you just look here, I'm not getting this cluster ID attribute. Sorry, this thing. So what I've done is just allow editing of contents, dive inside, and under the part where it transforms the pieces in here, I'm just telling it to copy over the cluster ID. So that way, when we run the sim, we're getting that cluster ID attribute copied onto these points. And if you have a look at what that looks, random from attribute and cluster ID, I'm getting all these nice clusters. Although, now that I'm thinking about it, we could actually use the name attribute. Yeah. So I'm using this to generate random number in the pop axis forces around here as well, here. So the random works on the piece itself, and not on individual points. But yeah, now that I think about it, we could have used the name instead, but you could do it a couple of ways. Generate an integer from a name, but this was the easiest way. Just creating a cluster ID attribute on the simulation points, diving inside a W source, and copying that attribute onto our geometry. So we have that cluster ID attribute. Awesome. So there's that. So another thing that I want to show you guys is how I point replicated these guys in here. So first of all, if you just put down a point replicate node, we have that density attribute from the debris source. So I'm just going to copy that and generate from that debris source. And this shape, sphere maybe, and something like that. We tell this to be scaled, so it stretches along the velocity vector. But now that we look at it, it looks strange. It's not scaling the way it's meant to be scaled. So the reason why is that this shape parameter tab is using the normals to rotate the shape of whatever we set to here. Change the orientation of the shape. So if we just delete that normal, and now we're getting the correct expected result for the replicate node. Scale this up a bit. Awesome. So now that that's working well, now we're getting some nice trails. What we can also do is, since we have the age and life attribute, we can actually create a normalized and age. Just gonna clamp it first. Age divided by life, and we'll get a normalized age. And what I want to do with this is I'm just gonna check if I have a p-scale attribute. I don't have a p-scale attribute, so I would say f at p-scale equals f and age. Boom. And what we expect is it would start off small and then gradually get bigger, but we want the inverse of that, so I would go 1.0 minus nh, and that's the complement of the nh. So we start big and then we go smaller. Zoom, zoom. Oof. So that's cool. Also, I noticed that I didn't add, I didn't correct these on my setup. So this is a better way of doing it, I guess. And saying keep input geometry, copy source attributes, and set the inherent velocity and radial velocity 0.23. Cool. So I think that's pretty much most of what we need for this sim, for the source of the sim. And under the collisions, all I'm doing is grabbing the collision geometry from the grains Kickup and adding some thickness to the rest of the geometry. So we've got this flat grid, and all I'm doing is splitting that, grabbing that flat grid, extruding volume, and merging it back with the centerpiece. Converting that to VDBs, and that's it. It gets fed into the popnet as a static object. Very, very standard. That's really most of what I've done. Cool. And then after caching that out, I'd be very curious to see what I've done for after all the changes. Let's have a look. Oh, fuck me. Oh. So I'm just gonna take that, point replicate. We'll see what this looks like. Run sim. All right, welcome back. So that's been cached already, and what we can see is something cool. Boom. Bam. That's pretty neat. We got very stringy bits though. Compare that with the old one. I still prefer this. All right, so there's that. And all I'm doing here is coloring these particles based on the cluster ID, setting the p-scale, and recomputing the velocities with the acceleration. All right, so that's it for the grains Kickup. Really, it's not super complicated, but it adds a lot to the look of the sim, of the whole thing. All right, cheers, bye.